All right, hello, welcome back. We are getting ready to jump now into a real world application or somewhat of a real world application as close as we can come here in just a short program. But what I've got here is a video 11. We've got a traffic light control program that I'd like to go through. And this is just, really basic, not very detailed. This could be done differently, but basically I want to go through and just kind of show step by step the implementation of this using ladder logic and how I decided to go ahead and structure this. So basically, when you think about it, we're just going to have a four-way type traffic stop. Um, all right, so we've got just a four-way traffic stop. We basically have a road. Think of this as a road. We're going to have a road going north, south, another road going east and west. And actually, in our example, we're going to have a traffic light. I believe this diagram only shows two traffic lights, but imagine that we have traffic lights at all four intersections with red, green, yellow lights, so that we can control um, the intersection for all the roads involved. And just the general sequence that we're looking at here, we can think about, well, gee, how do we want these lights to work? And we're just going to assume that when we start this, we're going to say we want the roads that run north-south, we're going to have those be green when we start this up. And then the east and west would need to be red because we don't want the traffic to collide. And then at some point, after a certain time, we'll have a timer, and then eventually the north and south will turn yellow, just to warn the drivers that, hey, we're getting ready to turn red there. The east and west side would still remain red. Let me go ahead and turn on a pointer here to point this out. So east and west would remain red. Um, and then eventually your north-south would go from yellow to red. And then your east and west would turn green at that point. So now the traffic can move, travel east and west. And then after some time, you're going to go from green to yellow on the east and west. And when that happens, the north and south would still remain red. You don't want them to go yet because the traffic is clearing the intersection here. And eventually, the east and west would go from yellow to red, and then north and south would go back to green. So basically, this step here is the same as what we have up there. So that's kind of the general sequence we're going for, just really basic light management. And so if one of the things you want to do is define the PLC inputs and outputs. All right, so what you see here is just a simple Excel spreadsheet that I created just so that I could list out the I/O for myself. And keep in mind, we're using an emulator for a MicroLogix PLC, and I'm actually going to be using a MicroLogix 1000, just a very basic MicroLogix processor. And as you remember, and when we talked about inputs and outputs, my inputs I'm going to be starting at I:0 /0, which would be my first bit, the first input. Remember, these are numbered 0 and so on, 0 and continuing on up to 18 are the ones that we're going to use. And I've decided to assign the first input to north red and then north yellow and north green. Now you might be asking, well, what are these inputs? Well, I'm going to assume that these traffic lights have confirmation that they've been turned on. That could be like a relay auxiliary contact, something like that. We're just going to assume that because we're going to use the outputs, remember the outputs here are going to be telling the lights to turn a color, like O:0/0 will be north red, 0/1 is north yellow, and then 0/2 is north green, and so on. When I turn one of these outputs on, that tells that light to turn that color. And then what I'm going to have is I'm going to assume that I have these traffic signals have some sort of a confirmation saying, yep, I see your output. Here's a confirmation that I got it, and it's sending an input back to the PLC. just kind of a confirmation. So we're going to do that. You'll see that kind of logic a lot in motor circuits where you have an auxiliary contact. You know, if a contactor or relay turns on, you get a confirmation from that. And so that's really all that we're doing. But this is the layout of the I/O that we're going to use. This would be the inputs. And then at the bottom here, I'm going to assume that I'm just going to have a start button and a stop button. Imagine that there's some control station somewhere where I can start and stop this. And then I can also have, say, an emergency mode where I can just throw everything red. You know, for some reason, let's just say I need to have all the intersections go red at some point. Well, I could have a button that would cause that to happen. So that's kind of the idea here on the inputs. And again, the outputs, these are really just all for the lights. You know, I've got west red, west yellow, west green, and this spreadsheet kind of helps me lay that out. Okay, the next thing I want to do is I want to lay out the routines a little bit. Just think about this routines that I might want to use for this PLC program. And here I've got kind of an overview of what I've already assigned. Ladder 2, let's get that pointer back. Ladder 2 is going to be our main program, and that's normally when you program with a MicroLogix type PLC. It's nice to have a ladder 2 be your main program. For this one, I'm not really using the user faults or the high-speed counter or the STI. I'm skipping down to ladder 6. These are kind of pre-named routines in the MicroLogix. Ladder 6 is the other important one. So ladder 2 and then ladder 6. Ladder 6 is I'm just calling it auto light, which is going to be the sequencing for the lights. And then I'm going to have a separate routine just for the outputs, ladder 7. That way, I like to do that. I like to have a routine where I just have all the output coils in one routine. It makes it a little bit easier in my opinion, for troubleshooting. All right, the next thing I wanted to cover here was this spreadsheet that I have. Um, Sometimes I use a start routine. I don't really have that set up for this one. But what I wanted to do is I've got a spreadsheet and I like to lay out kind of the basic sequence that I'm looking at when I'm writing a program, especially for something sequential like this. And I like to kind of lay it out with step numbers and then basically say, oh, okay, step 0. Well, what am I doing here? The start button. And then what I like to do is I say, well, what is the start button? The start button is I:1/0. It would be this input right here. And all right, so yeah, step 0, I've got start button, which I got I:1/0 as the input. Now, let me try to explain a few things here. What I like to use is I have something I use called like an operation and process bit, which is just a bit that when that bit is on, and it's just going to be like a normally open contact here, but when that bit is on, that means this operation is in process. When this operation for step 0 is complete, then this B310 will be set and turned on. Now the conditions to complete for step 0 are pretty basic. I just need to have the start button pressed, which is my first input, I:10. So that's pretty simple. And then step number 10, I'm going to say command the east and west lights red, command the north and south red. So my starting condition here is going to be all 4 lights will be red. When that operation is in process, B301 will be on. Now, what are the conditions for completion? Well, I want to get inputs back for the north and south lights that they are on. And actually, I want the same for east and west, so I don't believe I have that shown here. I'm saying I want east and west red and command north and south red. Well, let's take a look at our I/O sheet again, and let's see. I said north and south red, so 0, 0. South, wait, that's the in. We want the inputs. So north red, south red would be 4. East, so 0 and 4. So let's go back and take a look at this sheet. I've got 8 and 12 in here, right? So far. So 8 is east red, west red. Well, I also want north red and south red, so that would be the 0 and 4. So let me add those two in here. I'll just put them underneath for right now. So I want to basically see these in here as well, but we can fill this out as we go through. And then the timer, I'm going to have a timer T40, which is basically going to hold these lights red for a certain amount of time. And this is the done bit, T40 done. So that's one of the conditions for completing this sequence. And again, my step complete would be B311. This is going to make a lot more sense when we get into the program. And I can show you a little bit more about how that's actually laid out. But we also have outputs for active outputs. So if I'm going to have all these lights red, I'm basically turning on O08, O012, O00, and O04. This corresponds to all these lights being red when these are turned on. And then I just made a little note off to the side, like what I want my timer to be set at. Well, for this step, I just want all lights to be red for 5 seconds. So I've got, T40 preset equal to 5. And if you need to, you can go back and review the timer section that we went through earlier. But again, you can see here, I've got some of the input conditions here for some of the lights, the return comments, but I do need to add, I've got like north and south and east and west. So like the next step here, I'm saying command north and south green, keep east and west red. And then step 30, command north and south yellow, keep east and west red. All right, so then command north and south red, keep east and west red. So now they're all red for a short time. And then I'm going to say command east and west green and keep north and south red. And then after a while, I'm going to say command east and west yellow, keep north and south red. So basically, north and south will be red all the way up in here. And then we're going to say just jump back to step 10. So after step 60 is complete, we would jump back to step 10, where it basically just commands them all to be red again for 5 seconds. But you can see I've got different amounts of time for these different steps. Like for here, I've got a 10-second timer, 5 seconds, 60 seconds, 60 seconds, and so on. But what this does is this kind of helps me think about the program before I actually go and code it. All right, so yeah, here I've got a little bit more filled out where I've got the input conditions for all the lights. So, for example, step 10, I'm saying command east and west red, command north and south red. I wanted to put the confirmation inputs in here, and also the timer. So if you can see for each of these steps, if I'm saying command north and south green, that's I02 and I06. Keep east and west red, that's I08, I012. And then plus I have my time delay in here, T4. 1 is the timer, and I know the preset will be 60. Again, this is kind of rough. I'm going to include these sheets I'm going to have some notes where you can download these and get a hold of these, and or I can send them to you as well. But it might be helpful if you see this along with the program and take a look at the two together. All right, let's spend a little bit of time looking at the code here. Okay, so again, you see the programs that we've got here. Ladder 2 is the main program. Um, First of all, let's go take a look at the controller that I'm using. Again, I'm saying this is going to be a MicroLogix 1000, so a pretty simple program. Ladder 2, I'm calling that the main program. And all this is really going to be for is going to have the JSR instructions, which is a jump to subroutine. And so basically all this is doing is it's going to jump to subroutine 6, which is ladder 6. Ladder 6 would be in my auto light routine. And then the next one is U7. Well, they use U:7. But this is actually subroutine 7 or ladder 7. That would be my output routine. So basically, ladder 2 is going to call both of these. And basically, it's just going to scan through and call them all the time. But this is a little bit more structured way to program. When I first started programming, I used to throw everything in ladder 2, but you'll quickly learn that the code will be very confusing if you stick with that format. So it's not recommended. Um, we could take a look at the actual output routine. I'm going to go a little bit out of order. But what you can see here, I talked a little bit before about the spreadsheet, right? I was talking about the spreadsheet where I have these op in process bits, which I operation in process. And all that means is that I'm in process of this step. B302, for example, means that step number 20 is currently in process. And what I'm doing is I'm using those bits to drive the outputs in the program. So for example, if the step 40 operation is in process, or step 10, or step 50, or step 60, well, on those steps, I want north to be red. And then also I'm going to have this thing, which I'll go into a little bit more detail, is emergency mode, where I just want all the lights to be red. For some reason, if I need every light, north, south, east, and west, to all be red, I don't want anybody to move. I'm going to have a button, and I'll show you where that is, that will activate this emergency mode. And again, we can go down to north yellow. Here's north yellow, O:01. Step 30, if step 30 is in process, oh, look at that. We actually have a mistake in here. I've got this in here twice, which does not need to be there. So basically, step 30, right? I don't need to have that in there twice. So I can fix that. What we can do is I can go offline, uh, go over here, select that, hit the delete key. I'm going to go ahead and I can just verify the rung if I want to. I'm going to save it. And then I can download it. But let's take a look at our routine again, or our spreadsheet again, and just make sure, because it looks kind of odd. Only step 30 has north yellow. Let's look at step 30. Command north and south yellow. All right. Is there anywhere else that I tell north and south to be yellow? No, not there. Not there. North and south red there. North and south yellow there. North and south will be green here. And north and south red in step 10. So I guess that's right. That looks right, doesn't it? So step 30, I'm going to want north to be yellow. North will be green on step 20, according to the way this routine's written. Well, we can go back and double check that again, make sure we didn't make any steps, make mistakes in our steps. North and south would be green on step 20. Doesn't look like north and south are green anywhere else, so I guess that looks right. And of course, you notice the emergency mode is in here, which actually that should not be on every output, should it? We just got done saying we're going to have our emergency mode work only for red. Make everything red. So anywhere else that I see this, I want to take that out, don't I? I want to leave it here for red. I don't want it for yellow. We don't want it for green. We do want it for red. So you just get a little bit an idea of, like, when you're editing a program and you're getting rid of bugs and things like that. This is kind of the process you go through. Oh, don't want it there. Don't want it on green either, do I? Now, one thing I can do too, let's go up here. It's not tools. Not there. verify file, or verify project. So instead of me going up here and saying, well, I can verify this wrong, and I can verify that wrong, and I'd have to go up here and do these all individually, which could take a long time. Or I can verify the file, or just say verify the whole project. And when I click on that button, look what it does. It verified all those rungs. And then if I had any other edits and any other routines, it would also take care of those for me. All right, so I can hit the save again. And I think we're in pretty decent shape so far. So you can see here, I just have all the outputs and all the different steps. Step 40. So for the south red, step 40, step 10, step 50, step 60, and then the emergency mode. South will be yellow on step 30. South should be green only on step 20. What do we got here? East red, step 10, step 30, 20, 40, and emergency mode makes sense, I think. East yellow, step 60, um, step 50, east green. And again, here's another error. Let's see, that looks wrong. What is that? B335. We must have another error in the program. So east green. Let's take a look at our sequence here. Where is east going to be green? East, that's red, 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 yellow. Where is east and west green on step 50? B305. B305 is the only place. So that should not be there. We'll just verify that. Let's take another look again at that. Step 50. Yeah, east and west green on step 50. Looks like that's the only place, yeah, the only steps that east and west would be green. So I think we're good there. Then west red, step 10, step 30, step 20, step 40, and then of course our emergency mode. And then west, we have west yellow. All right, so we have west yellow, which would be step 60. Step 50 will be our west green. So I think we're okay here. We're going to go ahead and save it. And we'll still remain offline for the moment. We'll still go ahead and look at the actual auto routine. And this will help, hopefully, if you've got that spreadsheet with the sequence and you've got this side by side, it might make a little bit more sense. So what I did here in the first run is I'm basically setting up what I'm calling my auto mode. And I'm just going to have a start button. When that starting button's on, it should latch in this auto mode. You see I've got a latching circuit here. When I press the stop button, this normally closed contact would open, or if I hit the emergency mode push button, that would also drop me out of auto mode. And this is a pretty basic program. All I'm doing here is I'm just going to um, stop the sequence exactly where it is. I'm not really resetting lights to all red or anything like that. If it stops at a certain step with north and south red and east and west green, it's going to stop in that situation until I restart auto mode. All right, and then we've got the emergency mode button here, which is I018. And again, we have a latching circuit here to latch in our emergency mode. We can drop out of emergency mode by using the stop button or the start button. So if we are currently in emergency mode, I can get out of it with either one of those buttons. If I hit the start button, it's basically going to take me back to auto mode and drop out of emergency mode. And then here, what I'm using is I like to use sequence numbers I mentioned in the spreadsheet. I've got step 0, basically pressing the button. If the current step is 0 and we are in auto mode, Then I'm moving, this is a move instruction, move 10 into N7 colon 0. N7 colon 0 is an integer file, basically holding an integer value, and I'm using N7 colon 0 as my sequence step number. So I'm going to increment that by 10. Now you'll notice, especially you'll notice back here in the spreadsheet, that I'm counting by 10. And the reason I like to do that is because let's say later on I want to modify this program, and I want to insert a step between steps 10 and 20. Well, I don't want to have to renumber everything, especially if I've got a lot of steps in a program. I could come in here and insert another row, and I could call this step 15, and then have something, off here. I could, enter in all the information for that step. So it's a lot easier to insert that way if you leave yourself a little bit of room. So you'll notice in the PLC program, the first thing I'm doing here is I'm moving a 10 in, and then on this next rung, rung number 3, we have an equal statement. We're doing a comparison, and we're saying, okay, if N7 colon 0 is equal to 10, then I want to say step 10, the operation is in process, right? You remember those operation and process bits. This is what I'm using to drive the actual real world outputs for the lights. And then this is the step, the operation completed bit. Now, where does this get set? Well, actually, in this program, it's actually being set on the next rung, which is rung number 4. You'll see the coil for this op completed bit is right here, B311. And how do we complete this step? Well, if our step 10 operation is in process and the east red is on, the west red is on, these are our confirmation inputs coming back from the traffic signals telling us, hey, those lights are on. Um, Now notice that this program's actually not running at the moment, but these are already on because I've just preset them to be on just to make the program step through. Because I'm toggling these by hand since I don't actually have real physical outputs wired to a controller. I'm going to be using a software emulator to actually emulate the MicroLogix PLC, but just pretend that these are inputs that are being turned on when those lights are actually red. All right. Then what's the next thing I'm doing? As I have this timer T40. The time base is 1 second. Now, with these timers in these types of PLCs, you can have a time base of 1 second, you can have a hundredth of a second, or a thousandth of a second, or milliseconds. Um, I'm just going to make it simple and leave it at 1 second. Preset is 5. So what does that mean? That means this timer will time for 5 seconds. When this accumulator reaches 5, same as the preset, that's going to turn on our done bit for that timer. And here you see that we have our timer done bit, and then that goes to our step 10 op completed. Well, when that turns on, then that makes this normally open contact close. We move a 20 into our step number, which means the next thing we're going to do is go down and look and see if our step is now equal to 20. So the code is really all laid out really the same here. You got step 20, again, set up pretty much the same way. When this step 20 completes, we're going to put a 30 into the step number and go from there. And as these rungs go through, we'll go from 30 to 40 to 50 to 60. And then I think we go from 60 back to 10. But again, for step 20, when step 20 is in process, this is the one where we're going to be turning the north green on and the south green on. Now, these are the inputs coming back, right? These are not outputs. These are the inputs telling me that north green is on, south green is on. And then I've got my delay timer. Here I've got 60 seconds. So I'm going to let the north and south green lights be on for a whole minute. When that minute is up and this done bit fires, step 20 operation will be completed. When that's completed, this normally open contact closes, and that puts the 30 into my step number. And so on and so forth. So these are all laid out the same. Step 30, you see the same kind of setup here. I like to have code, consistent. There's other ways to do step sequencing. This is just one way of doing it. You don't have to do it exactly this way. There's other ways of doing it. But this is one way that's worked for me, and I kind of like it. I use this even in ControlLogix programming. But again, here's step 30. We're going to have north yellow on, south yellow on. And notice here, we're just going to leave those yellow for 10 seconds. So we got a little bit different timer setting here. But other than that, everything looks pretty much the same. And then we have our step 40. What's step 40 going to be doing? Well, step 40, it looks like north red on and south red on. Again, let's take a look here. Our step 40 operation and process B304. Let's just jump over to our outputs. We're saying that step 40 it should be turning north red on and south red on, right? All right, so let's go take a look at that. B304, north and south red. Let's see, where are those at in our out? Here's north red. Yep, there's step 40, right? Step 40, operation and process. That's one of the steps for north red. Where's our south red? Here it is, O:04. There is our step 40, operation and process. So you can see how these bits are being used to drive the outputs. All right, we'll go back to our routine here again, step 40. When step 40 for 5 seconds. Well, that seems a little bit short to me, doesn't it? Just to say, I mean, you can make these anything you want. You could say, well, I'll just leave it at 5 for now. But these can be changed. I could make that 10 if I wanted to, or 20. I could make that 10 seconds here. I think I'm going to keep it back to the 5 to keep it consistent with the spreadsheet that I've got. But again, you can change these numbers, make them anything you want. All right, you can see here T43 preset is 5. All right, so what's the next step? Step number 50. Same kind of layout again. Here, east should be green, west should be green. Step 50, operation and process, bit B305. East green, west green. All right, let's go take a look at our outputs. East green. Yep, step 50, operation and process. Where's our west green? Here it is, O:14. Step 50, operation and process. So that's driving those outputs. When this bit comes on, when this coil's fired, the normally open contact for that is going to drive the outputs. And then we should get a confirmation input back saying, yep, east green is on, west green is on. Go ahead, time the timer for 60 seconds. When the done bit fires, step 50 will be complete. When step 50 completes, we're going to move a 60 into our sequence step number here, and then 7:0. And then this is really our last step, and we're just going to keep looping around. This program is going to loop around and go back to, I think, step 10 when it's done. You can see that here. When we're at step 60, when step 60 completes, we're going to move a 10 into our step sequence number. So we're jumping back. We're not going to step 70. We don't have a step 70. We're just going to go back to step 10 and just keep cycling through over and over until we stop the routine. But the last thing we're doing of step 60 is we're saying we want east yellow on, west yellow on. And then when we're going to do that for, wow, I got that set for 60 seconds. That seems kind of long for yellow, doesn't it? I don't know that we want it to be yellow for 60 seconds. So what do we got here? East and west yellow, keep north and south red. Yeah, I don't think I want to. I'm going to change that to like 5 seconds. That seems, and again, you can play with this, and do kind of whatever you want. This isn't actually going to be in any real world application, but it's just something to kind of show you um, how you go about programming an actual sequence. So I'm going to change that to 5, and then we'll do a save. All right, and then real quickly, I want to open up the emulator again. So you can see here that I think I've already shown this before, like how you with RSLogix Emulate 500, you just select Open, you select the routine, which we could just have it called trafficlights.rss is the name of this routine. And I'm going to make this code available too for anybody who just wants the finished program. I would actually suggest, trying to enter it in by hand and get familiar with the editing. And but I'm perfectly willing to provide this too. I can provide this in the spreadsheets. But you open that, it's got to be compiled. So yeah, not a problem. But yeah, that's how you select that in the emulator. Um, what we can do here is I usually like to go to System Comms and double check, and it's like, yep, that's our MicroLogix. We're using the emulator 500 driver. So there it is right here. I want to do a download because we've changed the program. Yep, that's the one. Do I want to go online? Sure. Now, when you first go online, it's going to be in remote program mode. So I'm just going to change it to run. And right now, the program will be running. So yeah, this can also be useful. You can look at like the inputs. Now I mentioned before that just for simplicity, I already preset these with ones in them. These are the confirmation inputs, saying that north red is on, north yellow is on, north green is on. Normally you'd only ever have one of these on in a real world application, but just for me to be able to step through the program and just keep in mind, I don't have anything wired for real here. I'm simulating these inputs. I can go in here and easily change that to a 0 if I want to, or I can change it to a 1 if I want to. If I wasn't using the simulator and I was using real inputs, I wouldn't be able to do that. Basically, they would be dependent on whatever the input switch, whether it was closed or open. So that's really all that is. These are just those confirmation inputs. The outputs, this is, very helpful to look at. You can see here, none of my lights are on currently because I'm not doing anything with this system. North red is off, north yellow is off, north green is off. 0 would be off, a 1 would be on. And then, we're skipping an output, and then I'm going to O04, south red, south yellow, south green. All right, so if I want to simulate this program in the emulator, I want to go back to this auto routine. Now, what you can do here is you can right click on the start button and I can say toggle bit. Now, I'm going to assume these are like momentary buttons, right? So that my momentary button means when I press the button, the contact will close. When I take my finger off of the button, this contact will open again. So I can simulate that by toggling the bit on. And notice when I do that, it immediately latches in my auto mode. So my auto mode bit is on. Now let's say I take my finger off of the button. Oh, look what happens. This is still latched in, right? Because we created this latching circuit. So auto mode is still latched in. Now when we did that, we can go and take a look at our outputs really quick and just see what the current state is. Look at that. North is green, south is green because there's a 1, east is red, and west is red. So the very first thing we're doing, what step is that in? We are in, looks like step number 20 already. Step number 20, all right? Yes. There's step 20. Currently timing, we're at 53 seconds, 54, 55, 56, 58, 59, 60. Boom. Step 20 completed. So now we're going to 30. What's 30 doing? 30 is north yellow on, south yellow on. And it does that for 10 seconds. And then we're at step 40. You can see we have a 40. and then 7-0. And then it was a really quick 5-second delay there. We're up to step 50 already. We're moving into step 50. You can see we're timing on step 50. So east green should be on and west green should be on. And we can confirm that here. East green is a 1, west green is a 1. See, south is red and north is red, which is exactly what we want. You can look at your output program if you want to, and you can see step 50, operation and process. North is red. South is red. Step 50, operation and process. East should be green. Step 50, op and process. West is green. Step 50, operation is in process. So you can hopefully you're starting to get an idea of how this works. And you can see our timer's still timing here. We're keeping the lights green and red. And we should be transitioning over to step 60 here. Right now we did. There's step 60. We're timing for 5 seconds. And then what happened after that? We should be jumping back all the way up to step 10 and then into 20. So we're already back up here. We've already gone through step 10 and we're into step 20 already. And we're back to north green and south green. And this will just keep cycling through until we stop it. And one thing we can do to stop it is press the stop button. Notice that the stop button is a normally closed contact. So normally this is closed. You see it highlighted green, meaning that it will pass power from our power rail all the way to the end, if it can, which actually it's what it's doing now. We're making a path right around here and all the way to our coil. But as soon as I open that up by toggling the bit, look what happened. We just dropped out of auto mode. Now, if I take my finger off of the button, it didn't help us any as far as turning auto mode back on, right? Because this latch already had dropped out and we don't have our start button pressed. But as soon as I press the start button again by toggling this bit, we're back into auto mode again. And again, I can stop it. Whoops, I didn't want to force it. Remove that force. I meant to toggle it. There we go. So it's back off. So, we should be cycling. Yeah, we've got north red, south red, east green, west green, and where are we at? We're at step 50 here at this point. And again, like I said, when I stop it, it's just going to stop on whatever step it's on at that point. I'm not doing anything really fancy. But the one thing I do have is I do have this emergency mode. Now let's try it. Let's see if this works actually. So if I say toggle that on, and then we'll just toggle the bit off, we've turned on emergency mode. Well, if this thing works the way we think it should, that means our north is red, south is red, east is red. Oh, no, it shouldn't be green. West should be red, but west should not be yellow. All right, we may have a bug in here somehow. Oh, wait a minute. Let's take a look at this again. East, north green, north red, north green. Why is north green? Okay, because this operation is still in process. So that's not right. So we do have a problem here in the way the code is written. One of the problems that we've got is that when we drop out of auto mode, we really don't want to hold these steps in place like it was originally programmed, because that can be a bad thing. Because you can see what happened is we dropped out of auto. Step 20 is still active, which is basically still firing step 20's operation and process bit. So what we really, really want to do is we want this to drop out altogether. And I'm going to show you how to do that in this code. So what you're going to end up with here, when I have this code all done for you, it's going to be the final version. All right, so what is one way that we can fix this so that when we drop out of auto mode, I want to zero out our sequence numbers, right? When I'm in emergency mode, I want all the lights to be red. I don't want auto mode to be doing anything. I don't want any steps to be active. Well, I think we can fix that pretty easily. So we're going to just go offline because we'll do a save while we do that. So for these, some of these MicroLogix PLCs are certain models that you can do online editing. In this particular case, I cannot. I'm using the emulator, so I cannot do that. It would be nice if I could. Sometimes it's nice to do an online edit. But what I want to do here is I want to append a rung. All right. And I'm just going to say, well, whenever I'm not in auto mode, just to be easy, I'm going to copy and paste that. So I don't like to type if I don't have to. And then I'm just going to say an instruction here, and I can just type in OTE. You can use the menus up above. Sometimes I don't actually, not an OTE. I'd like to do a move. So I'm going to say append, and I know move is MOV, so I'll type MOV. I'm just going to move a 0. Let's see what this does. N70. Let's see if this works for us. Well, we won't know until we try it, right? We're going to download back. And we're going to start fresh. So I'm going to toggle that off while we're offline. You can do that. You can toggle these bits offline. And we're going to re-download. Go ahead and do that. Go ahead and do a download. And we're going to go back online. Again, we're in remote program. So I want to put it back to run. We're now in run mode. Let's see. We have nothing running here. Step number 0. We're going to go ahead and start this again because I want to get it going. Let it get somewhere further into the sequence here. All right, step 20. It's timing. Should be going through here pretty soon. So yeah, we're waiting for this. One thing I can do just for testing purposes is I can just bump that accumulator up to 55 just to speed it up a little bit. And that's just for me testing. Normally you would not do that, but I'm doing that just to hurry it along for testing. Now, let's say I'm going to throw it into emergency mode, right? Toggle. Toggle it back off. What does that do? Okay, we're out of auto. Auto mode is off. Let's see. What is our step number? Look at that. N70 is equal to 0. And why is that? Because I said whenever I'm not in auto mode, I want to throw a 0 into the step number. All right, let's see how that translates into our outputs. We're going to go under the data files. Let's take a look at our outputs and see what they are. North is red, south is red, east is red, and west is red. That's exactly what we wanted. We only want these 4 lights to be red. We don't want any other lights to be on. We don't want their automatic sequence to still be controlling anything. So that's what this rung here has taken care of that for us. Whenever we're not in auto mode, we just want this thing to drop out. Now, different machines, you may want to do different things when you drop out of auto. There's things like, an auto cycle stop where you may want to complete a sequence to the end. Let's say in this case, step 60, you want to get to it and then just stop there. You can do things like that. For this type of application, we don't care. We're just going to drop out wherever we're at. We just want everything to go red immediately as soon as we throw it into emergency mode. And so, yeah, that seems to be doing exactly what we wanted. All right, yeah, one of the other things I just want to cover real quickly is, you can, if you want to document a program, maybe print it out, you can do that. There are reporting options here as well. You've got this ability here to set up different things that you want to report. By default, there'll be a title page, some processor information, I/O config. You can uncheck some of these things if you don't really want all of that in there. Um, I probably would just go with the basic setup here, I like to at least make sure I've got all these ladder programs printed out. Again, I don't really care about these ones that I'm not using, so I could potentially come in here and uncheck some of these. And what you do here is you say select files. It's kind of strange, to be honest with you, but like now I can uncheck the ones that I don't care about. I'm not really using these, so why would I even want to waste paper or, waste the size in a PDF file? But I can apply it. You can play around with this and see what the different options are, but I can go ahead and do a print setup. Sometimes what I like to do is I like to maybe make this wider if I can. Looks like, what have I got in here? I've got tabloid, which I believe is equivalent to 11 by 17. I like to go landscape. I just print mine to a PDF. I have the Microsoft print to PDF option in here. So I can just hit that and it should generate a PDF file for me. All right, so hopefully that's been helpful. Again, that was kind of a quick walkthrough of this program. One thing that might be good for you is if you actually go through the keystrokes of entering in the program. I figure I've kind of gone through a little bit of how to create some of the rungs previously when I went through some of the individual instructions, but it might be helpful if you go through here step by step. But again, I'll provide the code, the actual program file as I have it here. And you're welcome to, if you have the emulator and RSLinx Classic, go ahead, download it, and give it a try.